Good evening, students, and welcome to this special AHA Guru session, which is a demo class for our live class program. Okay, uh, and this is for Standard 11, and I hope that is the students who have joined. Okay, my name is Ravi Shankar, and I am going to be taking this class, and I also am one of the teachers who will be taking the regular live class in 11 Standard. So I will just start with a very short intro about myself. Okay, um, uh, just give me a second. So I am a student from IIT Madras. I was also a faculty at IIT Madras before spending time on school education. Right. I have been in this space of teaching for IIT JE and uh, you know. Um, and other competitive exams coaching for quite a while, right? For the last 15 years or so. And I've helped thousands of students like you who to understand and fall in love with mathematics as well as also clear exams, right? So that is a very short introduction, and so I will today's class will be about probability. Just give me 1 second. I will also explain the process and how the mentors will be helping. So we have a system where people enter their doubts, answers, etc. in the there is an AHA Guru box where you can enter it. Sometimes we also do it in YouTube chat, so both are possible. So, and even watching the video, I think there are two ways in which you can do. The mentors will be able to guide that best. Okay, um, just give me a second. Just give me 1 second. There seems to be some small glitch. Just 1 second. Let me just get back to you. Okay, sorry for that. This thing, I understand also that there might be some, exams and exam stress and pressure for many of you at this point. Okay, so I'm glad that you were able to join this thing in spite of that. Okay, so let me go ahead and jump right into the session. So we are going to be talking about probability. Okay, and many of you are already familiar with probability, and you have learned probability in two ways, right? One is what is known as empirical probability, okay, which is defined by you do some experiment a certain number of times, and based on uh, the values or the results from the experiment, you define probability. For example, you say, let's say, toss a coin, you know 10 times, you get seven heads and three tails. So you say P of heads is equal to 7 by 10. Okay. Then there is a theoretical approach. Okay, this is what you will be learning in future. So where you say probability of heads is number of favorable outcomes by total number of outcomes. Okay. Okay, let me just come back. Yeah. So both are possible, right? Now the question is, um, okay, so let me just request the mentors to do a poll, okay, or a quick question on what, which approach you think is more correct, right? So number one, number two, either it can be a poll or it can just be a, your answer to a question, right? Okay, just give me a minute. So the mentors will ask you, okay, which and why, which do you think is a better estimate for probability and why? Okay, so I'll give a minute or so. Okay, let me just quickly see what are the. Okay, I think the the majority have said the second one, which is heads. P of heads is number of favorable outcomes by total number of outcomes. Okay. Now that is what you're usually used to doing, because you will write this as 1 by 2, and you will think that 1 by 2 is a better estimate than 7 by 10, because 7 by 10 happened just because of one experiment. Okay. um, Whereas 1 by 2 is what you would say is the theoretical approach, because the total number of outcomes is 2 and the number of favorable outcomes is 1. But the problem here is that this thing can lead to really bizarre conclusions. For example, suppose I ask, find the probability that there will be an earthquake in Delhi tomorrow. Okay. Now, what are the possible outcomes? The possible outcomes are yes, earthquake, and no, no earthquake. Now, if you go by this logic, if you say P of earthquake is equal to 1 by 2, well, you say favorable by total, but it is really not favorable. Okay. Um, but if you go by that logic, you'll get 1 by 2. Now, would you accept that the probability of an earthquake, I mean, you can replace Delhi with any other city in India, will you accept that it's actually 1 by 2? No, because something is wrong, because probability is supposed to give you an estimate of what will actually happen in reality. That's the purpose of probability, but that's clearly not what's happening here. So here we have a big problem, which is that this definition is actually wrong. Okay, this definition of there is a flaw in this definition. What is the flaw? The correct way of doing it is, the correct definition is, or the corrected definition, the number of favorable outcomes by, and what I'm going to do is, and this you have learned it, but many people don't say this at first attempt. Total number of equally likely outcomes. That means when you toss a coin, heads come or tails are equally likely. But when you talk of earthquake, they are not equally likely. Okay. So therefore, calculating probability requires you to know what are equally likely outcomes. But what does equally likely mean? Equally likely means equally probable. But this is cheating. This is a circular definition. You want to define the probability of something, but in that definition, you are using the concept of probability itself. This is exactly what is known as a circular definition, and is actually in in short, it's called cheating. Okay, and that's not a good idea at all. So how do we overcome this thing? In fact, what many of you may not know is that the way this is overcome is that we assign equally likely outcomes, or we define, cannot be assigned, we specify equally likely outcomes just based on our intuition and the context, not based on mathematically rigorous this thing. So what do I mean by that? For example, when a coin tossed, we say that heads come or tails are equally likely. That means we are already assuming that we have said, we have assigned P of heads is equal to P of tails is equal to half. When a die is thrown, we say P of 1 is equal to P of 2 is equal to, and so on till P of 6 is equal to 1 by 6. So that means we have said 1, 2, 3, 4, 5, 6 are equally likely. That means we have already defined the probability to be equal. Okay. That means we cannot prove prove that for coin toss P of head is equal to half, and for die throw P of, let's say, 2 is 1 by 6. This must be news to many of you. You cannot prove this at all, because if you think I can use the definition of number of favorable outcomes by total number of outcomes, I just showed you a very clear fallacy where that same logic will tell you that probability of earthquake in some city tomorrow is 1 by 2. Probability that you take absurd events, right? Some meteor will come and crash, in your particular classroom when you're writing the exam, it will be 1 by 2. Why? Because either it can crash or it won't crash. Okay. But this is ridiculous. That's clearly not. You don't go to write an exam with a preparation of 50% chance that a meteor will come and hit your classroom, right? Okay. Clearly that's absurd. So only when the outcomes are equally likely, you can put them in the denominator as total number of outcomes. That means you must a priori assign which are your equally likely outcomes. And this is the starting point for probability. I hope this is clear. Okay. If you have any doubts, let us know through the doubt box. Okay. You can answer through the doubt box. Okay. If you have any doubts, if it's any doubt is encouraged, perfectly fine. Okay. Anything silly, stupid, etc. is also fine. Only that will clear your uh, idea, right? Um, any kind of doubt or this thing is okay. If not, we'll proceed. Okay, if it's clear, we can proceed. Let me just take a minute or so, just because there's a new system for many of you. I just want to make sure that you are able to. Arnav has asked, okay, I'm hoping it's okay to use the name. If it's not, we also have a system where you can just specify, please don't use my name. Okay. Could you please define what equally likely means? Again, equally likely means equally probable or equal chance. So what we say is, we decide upfront that when we toss a coin, heads and tails are equally likely. We don't calculate the probability as half. We we say upfront that these are equally likely. After that, you cannot prove the probability is half once you have assigned it as half already. So what I'm trying to say is, okay, now what I call these as fundamental outcomes. Okay, okay, these are the ones that you assign as equally likely. If you toss a coin, heads and tails are fundamental outcomes. If you throw a die, tails comma heads in coin, 1 2 3 4 5 6 in die, then any one of the 52 cards, ace 2 3 till king of, let's say, clubs, then ace 2 3 till king of hearts, spade, diamond, 52 cards. These are when a card is picked. So the probability that P of, let's say, 10 spade is 1 by 52 is not proved. You have assigned that all of these, picking any of these cards is a fundamental outcome that equally likely. Okay, I hope that is clear, Arnav. Okay. Um, Now, so with this idea, we can now define probability better. But before we go into probability, we define what is known as a random experiment. Okay. Now, what we have been doing so far is random experiment, right? Where, like for example, tossing a coin, okay, throwing a die, etc., are all random experiments. Okay. Now, um, so what are the characteristics of random experiments? Okay, it should have more than one outcome, and it is not possible to predict the outcome in advance. Okay, so if you toss a coin, you can get either head or tail, and you can't predict which one is going to happen. Same thing with throwing a dice, etc. Okay, now sometimes we may just call it as experiment instead of random experiment, and every result of an experiment is what we call as the outcome. Okay, like for example, getting tails is an outcome, getting 3 when you toss a coin is an outcome. Now the set of all outcomes of an experiment is the sample space of the experiment. Okay, so it's a set, it has a certain number of elements. Okay, now set is an idea we will learn later, but it's okay, you intuitively understand what I mean by set, right? Okay, there's a notation, symbols, etc., but those things we can bother later. So for example, okay, tossing a coin, the sample space is the two outcomes, head and tail, right? Okay, then throwing a die, the sample space is the outcomes 1 2 3 4 5 6. So these are fairly easy, right? So far, I mean, you may be even thinking, sir, if this is what probability is, why do we even need a separate theory and a chapter, etc.? This is all very straightforward and intuitive. Okay, correct? And you're right. I mean, if you think so, you're justified. Correct? It doesn't require separate theory and a class, but what you will find is that soon things can become slightly more this thing. For example, suppose we toss two coins. What is the sample space of this experiment? Now we have coin 1 and coin 2. So we observe the results of both. Now suppose you say it can be, some people may say it can be head or tail, but which coin are you talking about? Some people may say it can just be one head or two heads. Okay, but the correct way of defining is clearly listing all the possible fundamental outcomes, and the possible fundamental outcomes are: coin 1 can be head, coin 2 can be head, coin 1 can be head, coin 2 can be tail, coin 1 can be tail, coin 2 can be head, and both can be tail. So the sample space is the combination HH, HT, TH, and TT. So you have four possible outcomes in the sample space. So you see, an experiment can involve something more than a trivial one coin or one die, etc. Okay, and the more complicated the experiment, the more you have to think about what are all the possible outcomes. Okay, okay. So why don't we do now? Go to the worksheet. Now, before that, if you have any doubt, let me know. Okay. Okay. So what we do is we will post questions from the worksheet which you can solve. For example, find the sample space of this experiment. Okay. So the sample space is going to include the outcome for pen color as well as coin or die, depending on the color. So let's see how much you're able to understand or make a guess. If it's wrong, it's fine, right? Okay. What do you think is the sample space for this experiment for question 1? Okay, we are still waiting for some answers. Let me just see if anybody has posted. Okay, I think people are having some doubts or some this thing. Okay, so let's look at what are the possible outcomes in this experiment. Two pens of red and green colors are there. A pen is picked at random. If it is red, a coin is tossed. So now think of what can happen if the color is red. You can get head or tail. Okay, and if it is green, you can get one, two, three, four, five, six. So, what are all the items in the sample space? The items are you can get red and heads, you can get red and tail, you can get green 1, green 2, green 3, green 4, green 5, and green 6. These are the items in the sample space. Okay. See, this is a combination of two experiments almost, and that's why it's a little tricky that many students found. Okay, they said they are not finding it easy. That's okay. Okay. The next question hopefully is easier because we have already done the two coins version. Okay. Now this is a thing with three coins. Okay. Coin is tossed three times, find the sample space. So let's see if you can find the sample space. Okay. Please try and do question 2. So this is similar to tossing three coins. Okay. Okay. I think a few people have got this right. Okay. Um, okay. So the correct set of responses, okay, is that sorry, the correct set of outcomes. Like quite a few have got. Okay, I just got one more. Kunal Manish has also got it right. Okay. Um, Let me just check. Okay, so when you have, so this is first, second, and third. So you can have head, 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 heads, heads, tails, heads, tails, heads. See, you see a pattern. First, I start with all heads. Then the second one is head, and then the third one changes. Then the second one becomes tail. Again, the third one becomes H and T. Now I have to go back and change the first one itself. Okay, this can be T, 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 T. And here again, first I'll start with head. I will get heads and tails. Then I'll have tails, and then I'll have heads and tails. So you see, 4 plus 4, there are 8 outcomes in the sample space. So the sample space is HHH, HHT. Okay, quite a few have got it right. Okay. Now let's move on to the next question. Just give me 1 second. Okay. What do you think is the sample space of this experiment? Question 3. Okay. A box contains 2 black and 3 white balls. Okay. So please note, okay, I can give you a hint. Okay. Label the black balls as B1, B2, and label the white balls as W1, W2, W3. See, even if you get it wrong, it's okay. Some students are worried that if it is wrong, they will be See, in our class there is a rule that whatever you this thing, it's fine. Okay, we can also um, not read out the name if you wish. Okay, anyway, so let's come back. Okay, so the sample space for this is, now look at all the possible combinations. Two balls are drawn. Okay, and what you're going to find is that the possible combinations are, of course, b1 b2 is one combination, that is two blacks. Then w1 w2 w1 w3 w2 w3, this is two whites. Then what about one black one white? You can have b1 w1 b1 w2 b1 w3, and similarly b2 w1 b2 w2 and b2 w3. So if you list all the possible outcomes, there are 10 outcomes in the sample space. Okay, I hope this is clear. Okay, now why is this important? Why do we have to go through this whole sample space idea itself? Because sample space is what will tell us the total number of outcomes, and hopefully or in most situations we would have listed equally likely outcomes. For example, here in this problem, all these 10 outcomes are equally likely. Why? Because we assign it intuitively. Like I said, there is no proof. Okay. Now, what you cannot say, suppose you say, I will have two blacks, two whites, and one black, one white. Now, suppose somebody says this is the sample space. Okay. First of all, this is wrong because this doesn't list all the possible outcomes. And more importantly, this is also not equally likely. Okay. Clearly, if there are more white balls, it is more likely that you can get two whites compared to two blacks. Okay. So these are not equally likely at all. The whites and blacks are not in equal number, right? Which is the reason why this whole explicit listing of sample space is a very important idea in probability. Okay, as you go to higher classes. Okay, okay. Now there are more questions like this. Now at this point, we can now ask, we can define the theoretical probability as, okay, the number of an event. So it's okay, so p of an event e is number of outcomes favorable to e by the total number of equally likely outcomes, which is basically number of outcomes in the sample space. Okay, like for example, in fact, if I do, I will show you question 4. I will do it. Okay, an ordinary deck of cards contains 52 cards divided into 4 suits. Cards J, Q, and K are called face cards. Suppose we pick one card from the deck at random. What is the sample space? The sample space is A spade. Okay, I'll just call it AS. Then 2S, 3S till king spade. Then ace clubs, two clubs, three clubs till king clubs. Then ace hearts, two hearts till king hearts. Ace diamond, two diamond till king diamond. 52 equally likely outcomes in the sample space. Okay, so this is the first part. The second part is, what is the event that the chosen card is a red face card. Now the event E is equal to red face card. That is the description. But how do we write it as a set of outcomes from our sample space? We write it as E is equal to, red means it is either hearts or diamond. Black is spade and clubs. But it must be a face card. So you can have jack hearts, queen hearts, king hearts, or jack diamond, q diamond, and king diamond. So event E has 6 outcomes. Therefore, if somebody asked you for the probability of E, you can say it is 6 by 52 is equal to 3 by 26. I hope this is clear, right? That a red card, okay, that a red card will, um, red face card, the probability of that, that is probability of red face card is 3 by 26. So now, in situations where the outcomes are easy to list, then we don't need all this new approach at all. Whatever you learnt in 10th standard already, which many of you, in fact, will be using for your exams, etc., board exams and all that, right? You know it automatically. Okay, you know it easily. But the challenge is, what if it becomes a little complicated? Okay, that is when this whole idea of whatever we have learned will come in really, really useful, right? For example, please see if you can do question 5. So you have to list two things. What are all the outcomes in the sample space? And event E is at least one tail. So list the outcomes in event E. So then find P of E. Please do question 5. Okay, a few students got it right. Very good. Okay, so the correct answer is, the sample space is HH, HT, TH, and TT. the event E at least one tail as HT, TH, and TT. So the P of E is 3 by 4. Okay. Now, the purpose of doing this is to make sure that we know clearly how to arrive at the answer with confidence. Not that, okay, can we do this, can we do that, etc. Okay. So that is the purpose of doing this thing properly. For example, okay, now let's go to question 6. Let's see if you can go do question 6. A pair of fair dice are rolled. What is the probability that the sum of the numbers seen is a multiple of 3? Now, here you have to systematically list the sample space. Okay, you don't have to list everything, but you must get an idea of how to do. Okay, so in this question, I'll give a couple of minutes for you to solve, but I will also tell you what is a wrong way to do the sample space. Okay. Okay. So the correct way to do this is the sample space contains all the possible pairs of two numbers, right? Now, pair of Faraday. So that means you can have die 1 and die 2. You can have 1 1. So 1 2, 1 3, 1 4, 1 5, 1 6. Similarly, if die 1 has 2, then it will be 2 1 2 2 till 2 6. Similarly, 3 1, etc. So the sample space will contain 36 outcomes. 2 6 and so on till 6 1, 6 2, 6 3, 6 4. 36 possible, 36 equally likely outcomes. In fact, this question is very, very important. This is one of the most common misconceptions. So understand, please follow this part very carefully. Now, out of these, which are the ones that are uh, uh, just give me a second. Which are the ones that are multiple of 3? So event E is outcomes where the sum is 3. Sorry, sum is a multiple of 3. So 1 2, right? 1 5, then 2 1, 2 4. Okay, then 3 3, 3 6, then 4 2, 4 5, 5 1, 5 4, then 6 3, 6 6. So here all of, so I'm listing systematically. So here the sum is 3 6 3 6 6 9 6 9 6 9 9 12. Okay, these are the possible things. Now you count it, you get 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 possible outcomes in E. Therefore, P of E will be 12 by 36. Total is 36. 12 is your favorable, which is 1 by 3. Okay, the people who have got it right are Kunal and Deepthi. Okay, others have not got it right. Okay. Um, Now, one common mistake that people do is they look at the sum. Okay. Okay. So, mistake which you have to avoid. Possible values of the sum of the numbers. See, if you throw two dice, the possible values that you can get are 1 plus 1 is 2, then 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, these are all the possible values of the sums. Now, sums divisible by 3 equals 3, 6, 9, and 12. Okay. Now, if you count this, this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 items. The and the sums divisible by 3 are 3, 6, 9, and 12. So you will get P of E is 4 by 11. And this, my dear students, is wrong. In fact, this is wrong because the list of outcomes you wrote, yes, the sum can be 2, 3, 4, 5, 6, 7, 8, 9, 10, 12, but these are not equally likely. Now, why is that the case? Because the fundamental outcomes here is when you throw two dice, what are all the possible combination? 1, 1, 1, 2, etc. If you think the sum being 2, 3, 4 is fundamental, then we differ. Okay? Because think about it. Do you think the sum of two, sum equals 2, can be attained only if both dice show 1? But sum equals 7 can be attained if both dice show 3, 4, 4, 3, 5, 2, 1, 6, so many different ways. Do you intuitively believe that these two are equally likely? If you have played any board game that involves dice, you know, in fact, there is a very popular game called Settlers of Catan, which is actually based on probability. Okay, it will tell you that the probability of getting a 2 when you throw two dice is much smaller than the probability of getting a 7. And anybody who has played Catan will know it. But the foundation behind that is probability. Now, if you say, now, if you ask me, sir, how do you prove this? There is no proof. I have to just appeal to you that look, boss, intuitively the fundamental equally likely outcomes are 1, 1, 1, 2, 1, 3, 1, 4, 1, 5. Each of these is equally likely. The sum equals 2, 3, 4, 5, 6, 7, etc. Yes, there are possible outcomes when you throw two dice, but they are not equally likely. Now, how do you, how do I prove? There is no way to prove it. What do you assume as equally likely outcomes is what is going to determine the probability. I am saying what is reasonable to assume is only 1, 1, 1, 2 till 6, 1, 6, 2 till 6, 6, etc. And not sum equals 2, sum equals 3, sum equals 4. And I'm giving you a logic for it. But beyond that, I can't say, no, no, that's wrong. Mathematically, I have proved. I have not proved. Because I am assuming that 1, 1, 1, 2, 1, 3, 1, 4 appeals better to intuition as equally likely outcomes. This idea is very, very important. In fact, this is the most important reason for doing whatever we have done today. If you have understood one thing, it should be this, that the fundamental outcomes that are equally likely have to be assigned by us, and after that only probability can be calculated. And that first step, many times books will not tell you, and even other teachers will not tell you. It's as if by magic it will automatically happen. No, you will have to make that thing based on intuition. And again, I'm telling you, there is no mathematical proof for it. Okay. So this is the part that is very, very this thing important. Okay. So you may say, sir, 4 by 11, 1 by 3, very, very close. But probability has to be exact. Okay. And in fact, if you say the probability of the sum being 2, so like for example, P of sum equals 2, in this case will be 1 by 11. 1 by 11, okay, is way different from, in this case, the P of sum equals 2 will be 1 by 36. Why? Because 2 can be got only by 1 1. 1 1 is the only thing. The E will be 1 1. And sample space will be all the 36 entries. So our method rightly tells us the probability of getting a 2 is very, 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 very low, which is why if you keep throwing pairs of dice, 2 or 12 will come very rarely. Okay, if you've also played what I don't know, the Ludo or Snakes and Ladders, when you throw the Indian version of those dice, okay, 12 is a very special thing. It will never occur easily, and people do assign it a like a rare event, right? And the reason why 12, that is 6 plus 6, comes rarely is because its probability is 1 by 36. Okay, whereas probability of getting a 7 is very, very much higher than that. Okay, so this is the key idea that we have learned today. Okay, the class was supposed to be only till from 6 to 7. We've extended it slightly. Okay, now the other questions in the worksheet, some of them we will, I mean, that was for a longer class. Okay, if you're not able to do them, that's fine. Okay, for example, question 7 and 8 you should be able to do as homework just based on what I have done so far. Okay, please do them. Okay, and if you have any doubts on whether the answers are right, etc., you can share it with our mentors also. Okay, if you have any other doubts so far, this is just a very small sample. I hope you were able to get some kind of a sneak peek of what probability means and why we have to do this. Equally likely outcomes is a big deal, right? And that's what I'm hoping is your takeaway from today's class. Of course, uh, our actual live classes in 11th standard will be 3 hours long, and we'll be doing many more problems. This is just to give you a glimpse of one small idea. Okay, there are other interactive elements that we will incorporate in a regular class. Okay, like for example, we have quizzes in many classes where it's something like fastest finger. So if you type fast, you will be within few seconds, then you will be able to um, get a better score, etc., right? And many other features which we will have in the regular live class, right? So since this is just a demonstration for a short time, we wanted to just focus on the concept alone within that 1 hour, right? If you have any other doubts, you can post. Otherwise, there'll be a mechanism to share your feedback. Okay, on how the class went, what you felt could have been better, or what parts you could understand well. Okay, do share your feedback. It will help us to improve future sessions. Okay, and I hope all of you will do your exams well. I know there is and the mentors have been telling me that in spite of exam pressure and difficult these things, students have come for this thing. I really appreciate it. Okay, and good luck with your exams also. Okay, so yeah, I think we will end the class here. If there are no doubts, I will just quickly check with the mentors. Yeah, there are no doubts. Okay, thank you, students, and all the best for your exams. Okay, good night.